In this lesson of 9.6, we're going to keep continuing what we've been doing on all the other ones. We've been working on tangent, sine, and cosine. And what we're going to do now, if you notice, is we're going to do inverse tangent, sine, and cosine. And so basically, inverse of something is when we do the opposite. And so essentially how they're going to help us is we're going to be able to take a triangle where we know the side lengths, and we're going to be able to find the actual angle measurements. So this first one, we're just going to kind of start off slow. So example 1, it tells us to find which of the acute angles has a cosine of 0.5. Okay, so if we think about cosine of A, we're going to see what its ratio is, and then we're also going to do cosine of B. Okay, so if I start off with my A, if I do A as my reference angle, this is going to be my hypotenuse both times. But for A, my opposite's going to be over here. Okay, so that means, and then my adjacent is going to be right here next to it, between AC. So cosine is my adjacent over hypotenuse. So if I do adjacent over hypotenuse, in this case, it's going to give me square root of 3 over 2. Okay, so just looking at that, that doesn't look like 0.5, right? 0.5 is the same thing as 1/2. Square root of 3 over 2 is not 1/2. So let's look at cosine B. So when I look at B, I'm going to switch my reference angle. My hypotenuse is still in the same exact spot, right? My hypotenuse is still going to be there. But now if my B is my reference angle, opposite of B is going to be the square root of 3, and adjacent is going to be the 1. So when I do adjacent again over hypotenuse, then it's equal to 1 over 2. So then 1/2 is the decimal 0.5. So whenever it says determine which of the angles has a cosine of 0.5, my angle would be B. Angle B has a cosine of 0.5. Okay, so it's important for us to be able to set these up, because now what we're going to do, like I said before, is we're going to take the inverse of those formulas. So when we work something and we end up getting tangent of an angle, if we take the inverse of it, then we can actually find the measure of the angle. Okay, so here's the core concept where it's going to show you how it works. But let's actually, I'm going to show you just how to solve these. So in this first one, it has let A, B, and C be acute angles. Use a calculator to approximate the measures. So when we have this first, we look at just A. So I have tangent of A is equal to 0.75. Okay, and I'm actually, let me move that over some so you can see how I work it. So tangent of A is equal to 0.75. The way that I do this is I'm going to take the inverse tangent of both these sides. Okay, so basically here I'm squeezing in this inverse tangent. Okay, usually inverse, it goes on the front. So on my left side of my problem, tangent, inverse, and tangent, they cancel each other out. So I'm left with, on the left side, just the measure of angle A. Okay, angle A is going to equal, and then the right side, I'm going to write it out exactly as I have it. I have inverse tangent of 0.75. And all this does for me, so then now instead of using tangent like we've been doing, when I plug in inverse tangent of 0.75, it's going to pop out an angle measurement. Now you do have to make sure, like I've discussed with some of us, and if you haven't realized on 9.4 and 9.5, to make sure your calculator and stuff is in degrees. But as long as your calculator is in degrees, when you do this, when you do inverse tangent, it's going to give you a value that's going to be an angle. And so when you take the inverse tangent of 0.75, you're going to get approximately, let me change this symbol real fast, because it's not an exact number. I'm going to get approximately 36, and it says nearest tenths place, so that's 1 decimal, so 36.9 degrees. So the measure of angle A is approximately 36.9 degrees for that first problem. If you're doing this on your phone, sometimes it's tricky to find the inverse tangent. It just depends. If you bring it to me, I'm more than happy to show you how to do it. on the calculator too. I can show you how to get those answers. So then with the second one, B, we're going to do the same thing. Okay, so if I erase all this, so sine B is equal to 0.87. Okay, I'm going to take the inverse sine of both sides. I just take the inverse of whatever function I already have there. So inverse side of both sides. Inverse sine and sine cancel each other out. Okay, and if you need to see that better, these two cancel. And so I'm left with just the B. And so that's my angle B, or the measure of angle B on the left side, is equal to the sine inverse of 0.87. So when I take sine inverse of 0.87, I end up getting that the measure of angle B is approximately, and it says nearest tenths again, so 1 decimal, 60.5 degrees. 60.5 degrees. And so as you can imagine, the last one's going to be pretty much the same thing. And so I'm just going to write it out again. So I have cosine of C is equal to 0.15. Again, I'm going to emphasize you need to be calling these properly. Don't come up to me and say, okay, I have cos C. That is not correct. You have cosine C. This is just an abbreviation, cosine of C. So I need to take the inverse of both sides in order to get rid of my cosine there. So inverse cosine. And on this side too, I'm going to do inverse cosine. My cosine and inverse cosine cancel each other out. So I get the measure of angle C is equal to inverse cosine of 0.15. When I put that in my calculator, I'm going to get my degree measure. Similar to like what we've done with square roots, a lot of times we're wanting to take functions of something and then we want to put it back in there. When I write the measure of angle C, when I take this function, I type this whole part in my calculator, this cosine inverse 0.15. Once I do that, I'm not going to write cosine again of inverse cosine or cosine. Don't throw that random stuff in there. You've already taken that function, you've put it in your calculator, and so when it spits it out, notice it doesn't say cosine of whatever the answer is. It just gives you a decimal. And so, again, this one is approximate because it's not exact. So this will be approximately 81.4 degrees. And so this is a degree measure. A degree measure it's going to have that degree, 81.4. It doesn't have a cosine. It doesn't have an inverse in there. Do not throw them randomly back in there. So the last thing that we're going to do is we're going to use this information now to be able to just solve right triangles. With minimum information, we can solve for everything else. Okay, we're going to combine what we've done from this whole chapter, all of chapter 9, all into this one section. So it tells me to solve the right triangle. So to solve it means we want every angle and we want every side. Okay, so what are we missing first off in this picture? Okay, notice we're missing this side of C, okay, the side AB that they've termed as C. We're missing it. We're missing this angle of B, and we're missing this angle of A. So I'm going to go ahead and write those out. We need to know what C is equal to. We need to know the measure of angle B, and we need to know the measure of angle A. Okay, in order to solve the right triangle, solve for everything, we need to find all three of those. So one of the first things, if we look at just C, we can solve for C. We already have two sides, we're only missing one. And so to solve for C, we can use Pythagorean theorem. Okay, so when I plug in Pythagorean theorem, I have this would be A, this would be B, this would be my C. So I'm just going to plug it in. So 3 squared plus 2 squared equals C squared. I get 9 plus 4 is equal to C squared. 9 plus 4 gives me 13. To get C by itself, I take the square root of both sides. So I end up getting that C is equal to the square root of 13. And that one does not simplify. So then we need to move on. We need to keep finding the other ones. So if I want to move on, I want to find the measure of angle B. So let's look at just our triangle with just B in there. A measure of angle B, I'm going to go ahead and just draw my triangle. I'm going to label my sides just based on B being my reference angle. So if B is my angle, this is going to be my hypotenuse. My opposite is across from it, so this would be my opposite, and this one would be my adjacent. So if I want to find the measure of angle B, I'm going to go ahead and use the whole numbers I already have. So if you notice, that means we have this 3, which is the adjacent, and we have this 2, which is the opposite. So think about the different functions we've had. Which one uses opposite and adjacent? Okay, either you have sine, cosine, or tangent. So like I said before, there's the kind of ways that you can remember these. You can use SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. So this stands for sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. You can also do some old hippie called another hippie, tripping over algebra is another popular one that I've heard, or whatever way that you need to remember it. So if we want to use opposite and adjacent, the one that uses opposite and adjacent is our tangent function. Okay, so tangent of an angle is always equal to the opposite over the adjacent. Okay, so in this case, my angle is B, so I'm going to plug that in. So I get tangent of B is equal to my opposite of 2 over my adjacent of 3. Okay, and we just learned how to find this. So when I have tangent of an angle and I don't know my angle, I'm going to take the inverse of both sides. Okay, so I'm going to take the inverse tangent of both these sides. So on my left side, the tangent and the inverse cancel. So I'm left with the measure of angle B is equal to the inverse tangent of 2 over 3. So when I plug this in my calculator, I'll be able to figure out what the measure of angle B is. And so when I plug that in, I get the measure of angle B is approximately 33.7 degrees. Okay, so my answer up here, I'm going to do 33.7 degrees. And so now I just need to find the measure of angle A. Okay, well if I have B, measure of angle A is easy. Either you can use what we've done before, or what we've been working on of doing the trig, and you can use sine possibly to find it. But if I already know B, then I can find A by just subtracting, right? Because if this is 33.7, all my angles in a triangle add up to be 180. So 33.7 plus my 90 degree angle plus the measure of angle A is equal to 180 degrees. I add those two and I subtract them from 180. So I end up getting 123.7. I'm going to subtract it. And so when you subtract from the other side, you end up getting the measure of angle A is equal to 56.3 degrees. And so that would be my answer. Okay, so then that means we've solved the right triangle. We have every part of our triangle now. Example 4, I'm going to go ahead and skip because it's just like the one we just did. You just need to identify your parts that you need to find. Obviously in this one you need to find G, you need to find H. And so you're going to have to use your trig right off the bat. You're going to need to use either sine or cosine to try to find your H or your G. And then you can find your other angle just like we just did. We already have one angle, so we add it up to 90, subtract from 180, and you can solve. So we're just going to go ahead and look at this last one. Your school building's building a raked stage. I'm not exactly sure what that means. But the stage, it says, will be 30 feet long from front to back with a total rise of 2 feet. You want the rake to be 5 degrees or less for safety. So I'm guessing a rake stage is basically they're lifting it up some so it's easier to see the whole stage, right? If it's really flat, it's harder for the audience to see. So we need to figure out if the current specs that they're planning on using, if it's going to give them that angle of elevation of 5 degrees or less. So remember, angle of elevation is when we start from horizontal and look up. So if we're at the front here, the stage front, if this is the horizontal, the angle of elevation is when we go up from the horizontal. And so we want that x degrees, it needs to be equal to or less than 5. Okay, we don't want it to be any bigger. So we can write that we want x to be equal to, or we want it to be less than 5 degrees. Okay, less than or equal to 5 degrees. So in order to figure that out, we're going to use those two sides. So if this is my reference angle, I have my hypotenuse here because that's my 90 degree over there. Across from my 90 is my hypotenuse. Opposite of my x is going to be my 2 feet. So if we have opposite and we have hypotenuse, that is going to be which one? Okay, think about SOHCAHTOA, S-O-H-C-A-H-T-O-A. So our function that uses opposite and hypotenuse is going to be our sine function. So if I try to do the sine of x degrees, okay, or in this case just the sine of x, it's equal to my opposite over my hypotenuse. So opposite over hypotenuse, in this case, we have 2 over 30. I can reduce that, so if you want to go ahead and reduce it, you could do sine of x is equal to 1 over 15. So, in order to get my angle measurement, this is where we said earlier we need to do the inverse sine of both sides. So if I take inverse sine, and I'm going to have to write it on the right side this time, inverse sine. So my inverse sine and my sine cancel. And so I'm going to end up getting, I'm going to have to write it over here to the left. The measure of angle x is equal to the inverse sine of 1 over 15. So I'm going to plug that into my calculator. And so when I do that, I get the measure of angle x is equal to 3.8 degrees. Okay, so is 3.8 degrees less than or equal to 5? Yeah, right? It's less than. So it asks us, is it within your desired range? Our answer up here would be yes. It's only 3.8 degrees of a rise.